Hi everyone, and welcome to MathSux. This video is going to help you pass the Algebra 2 Common Core Regents. So we're doing this one question at a time. Here is question 31. Biologists are studying a new bacterium. They create a culture with 100 of the bacteria and anticipate that the number of bacteria will double every 30 hours. So it's going to double every 30 hours. Write an equation for the number of bacteria B in terms of the number of hours t since the experiment began. So right away we know this is going to be an exponential equation. So before we dive into looking at the formula for an exponential equation and filling it out, let's just let's look at what this might look like if we graph it with using a table. So let's look at different coordinates. So if we have hours t and the number of bacteria, so starting at 0 hours, we are going to be we have 100 of the bacteria, right? Then 30 hours go by, it's going to double. So we're going to be getting 200, right? This is going to be times 2. Then another 30 hours later, so this is going to be now 60 hours from the beginning. We're going to have double again, 2 times 2, we're going to get 400. That's another times 2. And this would just keep going, this pattern. So now we just have like a little idea of the numbers we're working with and what this might look like on a graph. And now we can look at this formula. So the formula we're going to use is y equals ar to the x. So we're going to put this in terms of our question, but this is kind of just like the formula before we do anything, what it might look like if you look up what the exponential equation formula is. So just to go over what each of this represents, a right here is our initial value, which we know is 100, right? Because that's what we have before any time goes by, so we know this is 100. R is the common ratio. So what number are we multiplying every time 30 hours goes by? What number are we multiplying to the bacteria? That is 2, right? Because it's doubling every 30 hours. And then x is the time. So we know that it's going to be doubling every 30 hours, but this isn't 30 because we don't know how many hours are going to go by. We need to make an equation where t is the number of hours. We need to be able to make an equation where we can answer the question like how many bacteria are left after 100 hours, 200 hours, 400 hours. So in order to find that, this is actually going to be t for time over 30. And we'll look at why that works in a little bit. So now we just need to fill this all in and use it in the terms they ask us to. We want to find b, so the number of bacteria, b, which is like y, in terms of number of hours t, so that's b of t. So the number of bacteria in terms of time is equal to the initial value, 100, times the common ratio, 2, raised to the t over 30. So this is our answer, but I'm just going to explain that t value a little bit more. So the reason that works is because if we wanted to find out how many bacteria are there after 90 hours, let's say. So let's do 100 times 2 raised to the 90 over 30. Now we're finding how many groups of 30 hours have gone by within 90 hours. So once we do that, you do 90 divided by 30. So we're going to get 100 times 2. 90 divided by 30 is just going to be 3. So we know that the bacteria has doubled 3 times now. So if we look at our table and we go to 90, that's the next thing, the next group of 30, we would just double this again. So 400 times 2 is equal to 800. And notice we double the bacteria 3 times, 1, 2, 3. Algebraically over here, our equation works out because 2 raised to the 3rd power is 8 times 100, which equals 800 bacteria. So that's why this question works. But this is all extra all this stuff. All you really need to know to answer this question is right here, but this just kind of explains it all. And that's our answer. Need more practice? Check out MathSux.org for more questions. Link below. Also, don't forget to subscribe. Happy calculating!